Did everybody enjoy the party? It was okay. We just like to remind everybody that the talks are being live streamed. The link's on Twitter. If you use Twitter, retweet it, make some noise. That would be awesome. I'm extremely honored to present the next keynote speaker, as he's the creator of the language I first programmed professionally. So, without further ado, please give a round of applause to the keynote speaker of day 2, Larry Wall.
I'm going to channel RMS here. Repent! Okay. The Visigoths are coming, or maybe the Franks. I'm more Frankish than Visigoth. Imminent death of Usenet predicted. The singularity is near. Well, actually, I don't think it's going to be a singularity, but more of a plurality. The AIs will probably turn out to be more postmodern than we are, I think. As I learned yesterday, there are even 99 ways to count words in Python. Who'd have thunk? You said you didn't quite have a one-liner solution. Here's the Perl 6 one-liner solution. And it's sort of object-oriented. It's all methods, except there's no side effects, so I guess it's functional programming. I don't know. One of the very important lessons I've learned over the years is that most people really only understand technology from their own perspective, not from some global perspective. If you've been studying a new computer language for 3 weeks, then to you, that language is 3 weeks old. We get this sort of thing all the time on the Perl 6 IRC channel. Oh, wow, that's cool. I wasn't expecting that feature to work exactly like that, but it did. I mean, no, it's the other way around, isn't it? Anyway, us old-timers like to point out, yeah, we've only been designing Perl 6 for, what, about 15 years now. We'd like to think we got a few things right. But don't pay attention to us old-timers, well, except me today. You're probably new to Perl 6, even if you're an old-timer yourself. So please just think of Perl as a few months old. Forget everything you know or think you know about Perl. Just think of Perl 6 as an emerging language, a fairly big emerging language. We don't just include the batteries. We include the battery chargers, the electric grid, and several kinds of power plant. Okay, it's a really big language. Though still not nearly as big as English, but that's okay, because one of the design principles of Perl has always been that you don't have to know the whole language to start using it. Like a natural language, you can just learn the parts you need as you go. We also allow people to come to Perl from other languages and to speak with an accent, so to speak. So dialects are okay. In fact, many of the strengths of Perl over the years are based in linguistics. Languages evolve over time. We don't have arbitrary limits. You may only use 32 verbs in this paragraph. There are many paradigms, if you will, many small narratives you can have in English or any other natural language. Allow for external influence on design. Context is extremely important to everything. It's an operator-rich language we feel is more readable. We'll go more into that. Visual distinctions are important. Things that are apt to be confused should be made to look different. Languages are basically fractal in dimensionality. We had a speaker yesterday bringing that out. Your city is a kind of a fractal landscape. Easy things should be easy. Hard things should be possible. That's a very human thing to want. And you're allowed to speak comp sci when you grow up. On the other hand, many of the design flaws of early Perl resulted from me being more of a linguist than a computer scientist. You might say I had a better grasp of metaphor than of metadata. Sure, by the time we got to Perl 5, it had a lot of useful stuff in it, and it fit people's brains somehow, and it was lucky to be in the right place at the right time for people to bootstrap much of the World Wide Web. But it also had a significant number of design flaws. Perl 5 was nice, but not nice enough. At least that's what we thought back in the year 2000 when Perl 6 got started. In 2000, what we announced was that we would have a community rewrite of the language and of the community. As to what that actually turned out to mean, well, that took us 15 years to figure out. At first I thought we just needed to tweak a few things, so I asked for suggestions. I expected maybe 20, and we got 361. And they look like... and we did get a new Perl mascot. You may have seen the butterfly. Okay. Long story short, people were hurting in lots of different ways, and while there were many ideas for how to fix individual problems, the set of proposed solutions taken together were just a complete mess. So we ignored the solutions and just concentrated on understanding the pain. As we started to understand the pain points that people were experiencing, not just in Perl 5, but also in Python and Ruby and PHP and Java and C# and JavaScript and maybe even in Haskell a little bit, we started to come up with a list of principles that would guide the design of Perl 6. In the end, we came up with about 60 design principles, and here are a few of them. This is not the most important principle, except it is. How postmodern. We believe in tormenting the implementer on behalf of the user. As others have brought out here, we think it's a bug if the error message is less than awesome. We even have an acronym, LTA, for that. Every DWIM comes with a corresponding WAT. Try to hide the WAT. Encapsulate your cleverness and then reuse the heck out of it. So we only have about 2 lists that you have to memorize anymore in Perl 6, the precedence table and the smart match table. And we just use those everywhere. An A is just a funny kind of a B, but call it an A, not a B. We had a lot of this metaphorical stuff going on in Perl 5, like a class and a module and a package were really the same thing. The problem is we called them all packages, and that was confusing. In Perl 6, we actually use different keywords for them, which you'll see. Give the user enough rope. Every feature should have high leverage, but not too high. Remember, this is Perl. We're not actually trying to target only the geniuses. Pick the right default this time around. It's amazing how often Perl 5 had the wrong default. And everything should be made strangely consistent in this fractal way, and so on. So as you can see, Perl 6 is sort of a grand narrative composed of many smaller narratives. It simultaneously rejects the postmodern syntax, the polyglot of early Perl, but at the same time, it tries to do the same sort of postmodern mix together, but instead it's mixing together modern features of modern computer languages down at the semantic level. So we redid the syntax, but a lot of the spirit is the same. So we have a plan. No, wait, we have lots of plans. The art of design, of course, is to decide when to apply each principle. Each decision comes with trade-offs, but some decisions trade off more than others, so we had to figure out which were the most important principles. So I'd like to mention a few of the rather important ones. We think of flooding algorithms, we're talking about the freedom to perform multiple experiments in parallel and the freedom for some of those experiments to fail. And this is a difficult balancing act. We're an open source project with mostly volunteers, so most people will only work on what they're interested in. We feature that by declaring that we optimize for fun. On the flip side, we don't tell people what to work on much. We expect people to use their initiative. But usually when people use their initiative, they end up with something not quite optimal. As Theodore Sturgeon would say, 90% of everything is crud. So we need other sub-principles like forgiveness is greater than permission. While we encourage you to try things, we also encourage you not to get your ego too involved with your experiments. If software experiments never fail, you can never converge on a solution. Let 1,000 flowers bloom, but also recognize that evolution can't happen unless some of those flowers die young. Backtracking can be painful, but no refactor can happen without realizing you've gone down a blind alley. So in particular, I'd like to honor the Pugs, Parrot, and Nietzsche projects, which were among our most spectacular failures. We learned a great deal from each of those, and we would not be here where we are today without them. So where are we today? Well, we finally converged on Christmas. So the current version number is called 6.Christmas. Well, really 6.C. And what do we have? Well, we have a fun, handy, learnable, scalable, missed one, expressive, optimizable, maintainable, interoperable, and paradigm, gradually typed, Unicode friendly. It just keeps getting longer, doesn't it? Test suite specified, functionally reactive, parametrically generic, linguistically malleable, multi-virtual machine, meta-object protocol defined, representationally polymorphic, thingy. It's easy to slip into marketing mode here. If we want to do more marketing, it's racket without the parens. Yes. Yesterday during the Racket Manifesto, I kept thinking to myself, we do that too. It'll be interesting to see what actually happens first, whether Perl 6 makes Racket a sublanguage of Perl 6 or Racket makes Perl 6 a sublanguage of Racket. I warn you, it's a big language. Okay. Or how about this one? Perl 6, it's the last programming language you'll ever want to use. You can take that either way. We're not picky. One of our small narratives is that you can pick your own grand narrative if you like. But I think you'd rather just see some code to show that Perl 6 actually works and actually looks pretty decent. I can't show lots of examples here, but one place with lots of good examples of both Perl 6 and Racket is Rosetta Code. Well, not Rosetta Code / Perl 6. You looked on yeah. One place with lots of good code examples, you can compare the solutions of many different, hundreds of different languages. I think there's 500 of them or so. I think at the moment, well, I had that somewhere. Yeah, I think Perl's number 5. Racket's up above, yes. Okay, so anyway, Perl 6 itself has 800 or so solutions to those various problems, and I might be a little bit biased, but I think compared to other languages, Perl 6 usually comes off pretty well in terms of readability and elegance. One of those Rosetta Code problems is called forest fire. So first I'll run it for you. Wow, that's low res. Anyway, it's kind of mesmerizing, isn't it? This is a crude simulation of a forest ecosystem and wildfires. We start with about 50% coverage of virgin forests, and the fire burns up most of that, and eventually we settle down to a quasi-steady state. Now, there are two forms of propagation going on here. Trees propagate slowly, while fire propagates quickly. If I may draw a metaphor from this, many modern computer languages are like fire. They do one or two things really well that no other language has done well and suddenly become popular. But they tend to run out of fuel quickly. Sometimes I feel like we should invent a flavor of the month club for computer languages and web frameworks and container technology. Perl 6 is not trying to be the flavor of the month. It's trying to propagate more like the forest, slowly but inexorably. We don't really care if one of those flavor of the month languages eats up a bit of our forest. Wildfires are just a part of our ecology, and maybe they even help our seeds germinate. Anyway, enough of that. Show me the code. What? Drop the left edge? Okay. Okay, so where's that? Okay. Is that big enough to read? Okay. Notice, first of all, that Perl 6 is highly declarative, much more so than in Perl 5. You see many lines beginning with what we call a declarator. You have a constant, my for declaring lexical variables. Let's down there. As in Perl 5, enum, class, has, method, and so on. We also have declarative modifiers, which we confusingly call traits. We have something like small talk traits, but unconfusingly, we call those roles instead, because it would be confusing to call them traits when they are also functioning as interfaces and abstract classes and generics. So anyway, here, is required is an annotation that modifies the has declaration. Note that we hide our annotations inside instead of stacking them up out front like other languages do, and basically hide the name in the declaration itself. So important things first, modifiers later sometimes. Below that, you see other declarations that can take default values for these attributes. Notice we use actual words that you would use. I mean, a has a relationship, you declare with a has. Duh. So the default values, in this case, these are whether the trees will grow or catch fire. Notice we have optional typing there. We're gradually typed, so you can add more typing as you go. Yes, Perl 6 is highly declarative, but when we say declarative, we mean something a little different than usual. For most computer languages, if you call something declarative, it's fixed in stone. It's built-in syntax. You aren't allowed to change it. And we call this the one true language syndrome. Perl 6 doesn't suffer from this. You can add your own declarations and change the language within any given lexical scope. The compiler itself is written in Perl 6, so you don't have to learn a different language to modify it or to add your own declarators or traits. For example, we already have modules that implement things like monitors or actors as user-defined declarations. And it takes about this much code to introduce the actor model. We just try to, even if we don't fully support some particular, your very favorite style of programming, we're about this far away from it. So you can get there. In fact, most of the declarations you think of as built-in are actually just written in Perl 6. They're incorporated into the setting. That's what we call a prelude, except it's not a prelude, it's a round, so it's a setting. They're incorporated into the setting in the same way as user code, as if the setting were wrapped around your program as an outer lexical scope. Take, for instance, this X operator down here. That's, in many languages, the set of operators is fixed. Maybe even the set of behaviors for those operators is fixed. Because our setting is an outer lexical scope, you could override or add to the behavior of the X operator in your own program. I'm going to look at the definition of X, but first of all, maybe you're wondering, what it is. It's just a Cartesian cross product. So if I run this snippet of code, it just produces a list of lists. Likewise, this one up here, you'll notice is an X tilde. That's just a cross with operator. So that does, in this case, concatenation. So it's a cross with concatenation. Okay. I promised you I'd show you this. I think it's in lists. And okay, so here we have definitions of the X operator. The first thing you notice is the operators are really just functions with funny names. Well, and because of the funny names, the parser knows where to look for them. It won't be looking for an infix where a term is expected, for instance. This is extensible. Depending on your grammar, you can make as many different namespaces as you like. The next thing to notice is there are multiple definitions for the function. Second is the ordinary X operator, the one that returns Cartesian products as lists. The first one is used when you want to do higher ordered programming and pass in an extra function to apply to those Cartesian products. As you can see, there's a lot of extra stuff in there. That's that 10 times stuff to make something industrial strength. Some of these definitions are kind of ugly, you know, dropping down at the lower level language here. NQP is not quite Perl, it's a restricted subset. Now, this is all, you know, highfalutin functional programming internally, but notice how simple it looks in our actual program. Just with the X here, that's wrong. That one. Just with the X here, we just X here because we want to cross the coordinates multidimensionally. But up here, we can do the cross concatenation in a very succinct but yet readable. We use uppercase for those visual distinctions. It shows up in the middle of two lists easily. So if well designed, a system of operators can do more than almost anything else to contribute to readability. That's my narrative anyway. Well, one of them. What I'd really like to do is convince you that deep down, Perl 6 is really both fundamentally a functional programming language as well as an object-oriented programming language. Maybe not in the, you know, in the 90% sense, not in the extra 10% that says you can't use any other paradigms. So really what we like to think of is that we can make pretty much any programming style look more respectable than many of the languages that purport to specialize in that style. We certainly do a prettier Java subset than Java does, I think. Now, this 4 down here, for instance, these 4s look like imperative programming statements, but really, they're just map in disguise. For instance, you could turn it into, and that is, in fact, with the arrow there, that's one of our lambda notations. And because it's a general lambda, you can pass multiple arguments or do argument unpacking or pattern matching. Okay. Now, each of these methods is really a function underneath. The only difference is that a normal function is stored in your lexical scope and uses the function dispatcher. It's a part of your current language. A method is stored in the meta class object and uses a method dispatcher. So its language belongs to the class or the object, depending on your object style. On the surface level, most of the time, functions are entirely distinct from methods, and we work really hard to keep the naive users from confusing them. But down underneath, everything is unified, so you can install functions as methods or call methods as functions if you work at it. So when it comes to mixing paradigms, we always try to have our cake and eat it too, but not by forcing novices to convert from one paradigm's religion to another, but by maintaining deep unifications under the surface differences so that we can be both novice and expert friendly. Easy things should be easy, hard things should be possible. You may have heard that before. Okay, so Perl 6 is not the first language to claim multi-paradigm support, but that's just one of the areas in which Perl 6 is trying to raise the bar. How about, say, Unicode support? We saw a little bit of that in the Forest Fire program, where we used the tree character from Chinese. But what if you wanted to use a character outside the BMP? How does your language work with that? Can your language handle emoticons as single characters? Can you just paste any old character in your program? We could like change that from a regular tree to a Christmas tree. Don't have time for that. It works. But Unicode is not just for the insides of strings, it's also for the outsides of strings right there as part of your program. Perl 6 programs are natively Unicode-y. On a deep level, you can always define appropriate Unicode operators for what you're doing. This has the added benefit that you won't be tempted to overload an existing operator for an unrelated function. I'm looking at you, C++. Also, names may contain Unicode. This includes module names, even on file systems that don't know about Unicode file names. Interestingly, this gives us case-sensitive module names even on file systems that are not case-sensitive. But on a shallower level, handling Unicode just saves many irritations. How many of you have tried to program on a smartphone or tablet? How many of those clients do smart quotes? Does your favorite programming language accept smart quotes? So here's regular quotes. Yeah, that works. Creates a letter range. What about smart quotes? Yeah, no problem. What about if you're one of those other countries? What about if you're one of the other countries that puts the trailing quote the other way? That still works. What if your smartphone changes the dot, dot, dot into an ellipsis? Yeah, whoops. Have to actually run it. Okay, yeah, it works. What we're doing here is called NFG, a term we made up. And you can think of it as NFC on steroids. What that basically, well, let me demonstrate. Okay, suppose you want to have a moo with a vector notation of some sort on top of it, because you're some sort of a mathematician. Perl 6 knows that that is one character, but 2 code points. Okay, now here's a whole bunch of stacked marks, combining marks. How long does Perl 5 think that is? Well, it thinks it's 49 characters. Oh, oops, I should have said use UTF-8. Now the length is only 27. What is in Perl 6? Well, of course, it's 5, because we default to graphemes. Get down to the code points or the byte level if you want to. So, this doesn't mean much to the Americans, like me, who look with suspicion on any word containing accents. But maybe you want to work internationally someday. Even if you're European, chances are your characters will all have precomposed forms in NFC. But other languages are not so fortunate. It's one of Perl 6's goals to treat these languages as if they had first-class representation in Unicode anyway. And here's how it works. Imagine a distant future in which NFC is extended to have precomposed characters for all normal purposes. NFG is attempting to emulate that future. If there's already a precomposed NFC grapheme in Unicode, it just uses that. If not, Perl creates a temporary precomposed grapheme just in this process so that it can pretend that your composed form is a single character. This means that when you index into a string by grapheme, it's very efficient because it never has to skip over variable with characters. More importantly, it simply does what the naive user expects. Now, suppose you want to write your numbers in Tibetan. Well, that works. Suppose you want to write cuneiform numbers. Yeah, that works. Suppose you're vulgar and want to write a fraction. Yeah, that works. Well, yeah, but that's not an exact floating point. That's a floating point number, right? So it's not exact. Well, what is it? Actually, it's a rat. What methods does it have? Oh, gee, we can introspect numbers. Well, one of those is the numerator and denominator. So what are those? 3 and 5. Well, there's got to be a joke in here somewhere about the objectification of nude rats, but. Or you can ask for the Perl representation of it. Okay, here's a tricksy one. I don't think I need this anymore. Okay. So what's this going to say? If you add 2 decimal numbers and compare it to a third, most of your languages are going to say no. And no, it's not cheating by doing approximation. If you want a floating point number, you have to use E0 on your literal, or E whatever, okay? These default to rationals, okay? And it's what the naive user expects. I mean, if you're smart enough to really want the floating point, you're smart enough to figure out how to get them. Okay, well, so if you have like a series operator here and you're going up by 0.1 every time, is it going to actually hit the endpoint exactly? Well, in this case, yes it is, because it's done in rational arithmetic. So we have this lovely series operator, which you'll note is actually intuiting the sequence there. So what does this say? Well, it says, whoops, it says don't go to the next slide. It says, you're dumb, that's infinite, I'm not going to print that out. So you can say, well, I just want the first 40 of them. So you can subscript slice it with a range. This is a range 0 up to, but not including 40. You can put a caret on either end to exclude the endpoint. And that happens so often that we have a shorthand. The prefix caret operator says up to that. So those both say the same thing. Okay, now what about this one? Well, obviously that's a geometric sequence, so it's going to do powers of 2. What about this one? Oh, note the infinity symbol. Yes, that works too, if you want. Yes, it just gives you the alternating geometric sequence. Strange geometry. What about this one? Yeah, that works too. Sometimes it's just a lot prettier, and people know how to read that, you know? Why shouldn't you write your code to be readable? You can use ** too if you want. Okay, what happens if we ask for some Fibonacci numbers here? Well, it says, I don't know what you're talking about there. At one time, we contemplating baking in the whole online integer sequence thing, and we said, no, that way lies madness. So just arithmetic or geometric. But if the last thing in your sequence is an iteration function that has a certain arity, it knows how many things to look back for. So Fibonacci is just give it an operator that takes two arguments. So you can either use the built-in by name, that's the noun form of the built-in plus operator, or you can write a lambda in the long form, or there's a self-declaring form, or there's this sort of self-auto-currying kind of form that we have with the whatever stars. And those all do the same thing. More fun. Function composition. Okay. So you try to do a log of a negative number, and you're not going to get anything much out of it. But if you just always want to put my clock on here. Okay. If you always want to do that, well, leave that alone. Fold operators. Okay, so you can do it in method form if you really want to, but mostly we use the prefix list operator form, like this plus here. And so those all sum up to 10. Running sums, what you call scan in Haskell and such languages, we call a triangle operator because it tends to produce triangular-looking things. So you get triangular numbers, and those can all be lazy. Okay, so you're going to roll 6 dice, 6-sided dice, 5 6-sided dice like in Yahtzee. You can sum them or find the minimum of them. Okay, let's probably get a different. Okay, they do vary. So anything that's an infix operator can be reduced with, including user-defined ones, which we'll see. Okay, so you're reducing or folding with a star versus a star-star. Is it going to be a right fold or a left fold? Well, it just deduces that from the associativity. So these turn out to be both true. Automatic identity. Okay, so this obviously is a reduction which happens to produce 100 factorial. As I said, no arbitrary limits, so our integers just grow. Suppose you wanted to put that into a function. Well, let's define a postfix bang. You've never seen that notation before. So 100 factorial, same number. Okay, what happens here if I say 1 factorial? Well, you know, obviously it's just a range of 1 to 1, so that's still just 1. What happens if I say 0 factorial? It's still 1. Operators know their identity value. So if I just say this, again, it's just 1, even though there's no arguments whatsoever. Any infix operator, including chaining Booleans. So is 1 less than 2, less than 3, less than 4? Yeah. So what's the degenerate condition of that? It's true. Degenerate mins and maxes are infinity plus or minus. What's degenerate GCD? Heck if I know. Other meta-ops. The reverse meta-operator. Okay, let's define a beta infix operator, user-defined operator, and it just puts a bow tie between the two things. So reverse 42 and 43, it gets 43 bow tie 42. We actually have used this in anger sometimes. You wouldn't think so. Mostly due to end weight considerations. Sometimes you want to divide into something, so you use a reverse division. The zip meta-op, so zip width in the meta form. You can do plain old zip too. So that zips up 2 lists, as you would expect. Stops on the shorter one. The cross operator you've seen, that does the cross product. How about the reverse cross product? Yes, they stack. The X reverse, the cross reverse, beta. Yeah, it's something slightly different. And if you do it all the way around, you get back to where you started. So, yeah. When it gets ambiguous, you can put square brackets to clarify. So it does not always become unreadable. Well, I got, you know, there's plenty more I could talk about. In concurrency, we've got vectorizing hyperops that I really haven't. You saw one in that first top 25 thing, but we use promises and channels like Go does. Events, we basically have functional reactive programming stolen, I mean lovingly borrowed from C#, only we renamed everything to make sense. So you have supplies and you react to those supplies. And in general, the words that we choose in Perl tend to be the English words you use for actually solving the problem. We don't use switch case. That's talking about the structure of the program itself. No, it's given this, when that, when that, when that. Same with the reactive programming. Representational polymorphism. Your classes don't even know what the representation is because that's a layer underneath that says, oh, you're in our opaque kind of thing. We can do whatever we want. Or you're an array in your VM, or a C whatever, or a Python hash, or whatever. You don't have to worry about that on the language level. Just when you start it up, it has to know which one to use for each type. And lots of stuff with native types. Great foreign function interface these days. Metaprogramming is a meta object. Don't really have time for it. We use generics all over the place inside. We currently have 2.5 backends. One more VM, which is written in C. It's kind of our native VM, but JVM is close behind. And JS is in progress. It's the NQP part of it is fully bootstrapped, and they're just implementing the final few instructions there. Interop, so I'll probably stop there, and maybe you have a few questions.
Hey, with all these different ways that you can do, well, I'll take the example of codes, but I guess it applies to other things. Aren't you afraid that there may be fragmentation in programs in the sense that I have a hard time reading the program written by someone who is of another native language? I mean, I'm no English native speaker, but at least in most languages, I know that I'm going to see the English style of writing. And here it looks like it might be harder.
Yeah, certainly everything is a trade-off. And if you give people maximum flexibility, some people will take advantage of it. Our strategy there is we try to give people enough rope to shoot themselves in the foot, as it says, but we also try to include so many batteries that they're rarely tempted to actually extend the base language. And so at that point, if you're talking about programming in a different language, people are already programming in different languages. You've probably seen Chinese programs, and no, you can't read them unless you can read Chinese. I know a lot of the characters myself, but even I can't, necessarily read them. But so it's trade-offs. At some point, you're talking more on a level like literature. You can't read a Chinese novel until it's translated to English either. So it becomes a cultural decision rather than a technical decision or an imperialistic decision on my part. So whatever.
If your Unicode support is based on graphemes instead of code units, and we have combinations of code units that create like flags, right, based on the country codes, does that mean the length of my string will change over time as like global politics changes countries?
Yeah, well, we can't do much about politics, can we? Except vote occasionally.
So what went into the decision to use grapheme instead of code units?
It uses the grapheme rules that the Unicode consortium itself puts out. So we have them to blame if they change it.
Maybe I missed it during the presentation. Can you define your own meta operators?
It would be possible to. We don't quite have that hooked up yet. It will be. I mean, they're just another grammatical category. Well, actually, several grammatical categories, depending on whether it's an infix prefix or an infix circumfix or a prefix prefix or infix prefix or a postfix. Okay. There's lots of grammatical categories that you can add. Most of the common ones are hooked up. We don't have all the meta operators hooked up yet at that level, but the intent is that if you're willing to actually program inside the compiler, it would be trivial too, because the inside of the compiler is already Perl 6. It's just not, we don't have the way to hook that up into the user code quite yet. We're still working on our macro system. As was mentioned, hygienic macros are just a start of what you really need to do true language extensibility. And we have all the internals in place inside the compiler. We don't think of Perl 6 as a single language. It's a braid of many languages interwoven. So at every place where you're parsing a particular grammatical category, you're really in a kind of little different sublanguage. That's also true about regular expression languages, here docs, quote languages. They're all generated on the fly to the extent as necessary. So all the mechanism for mixing in new grammatical rules, deriving a new grammar, and it actually goes out and writes a new lexer for you with transitive longest token matching rules. So you never have to write a lexer again. So yeah, almost.
Thank you.
Perl 6 is a big language, but you said it's mostly written in Perl 6. So if I want hashling Perl and Racket, what's kind of the minimum part that I need to build? Is it, that's often hard to boil things down to a minimal, but is there a small piece that I could try to attack? Not attack, but I mean, try to build so that I can...
I don't know, we'd have to talk about that. It's, we because we are so, have such interwoven, this is runtime code running at compile time. It's sort of the dual of, eval is like running, evaluating string is like evaluating a compile time code at runtime, and we do the opposite also quite a bit, which is running code underneath in various pieces to do these declarational kind of things. So, and I'm sure there's a few places where we cheat on, well, I know there's places we cheat on context freeness. So it might, reproducing the exact semantics of our parser might be a little tricky.
So just to refine a little bit, that makes sense. And Racket, where we fall down and not being minimal at all, is the runtime system.
Yeah.
Right? So there's sort of a small core language with.
Why do you say that? Why do you say falling down there? That's a good thing.
We would very much like to be able to move it to other platforms. So,
yeah.
So I wonder what the trade-off. Do you have?
It does.
Like things like threads and I/O and all of that.
Yeah. At the moment, for a lot of this, we're relying on the libuv, the Node.js for a lot of our platform semantics. That's so yeah. That gives us some portability layer. The NQP layer, not quite Perl, is also designed to be fairly portable for a large language. I mean, obviously you have to support all this grapheme stuff and what have you. But if we were a tiny language, it would be easier to port to new places. But it's one of the many things we tried to bear in mind and at least make it possible, even if it's not as easy as it would be to port C.
Perl 3 introduced the taint mode. How well or not has the taint mode worked for you, and when will it be introduced in Perl 6?
Yeah, that's a bit of a, we haven't introduced taint mode in Perl 6 yet. We thought about it. It doesn't work quite so well when you have this representational polymorphism. Where do you store the taint bit? Where do you store the taint bit in a native integer? Well, maybe just don't taint them. Either you store something with the data value that says, oh, this is tainted, don't use it on anything insecure, or that's if you want the runtime approach that Perl 5 does. If you want a more, like a Rust kind of approach or more static, then, we can talk about that. We try to have a certain amount of information available at compile time so that we can do both ahead of time optimization as well as jitting. But yeah, you got to store it somewhere, and even if you have to have some sort of a descriptor or a some of these, as mentioned yesterday, when you're doing cross-language things, you have to have various kinds of proxies. Doing it with proxies that manage that is another possibility. But yeah, it's one of the things we didn't get in by Christmas because we wanted to get something out. We didn't even beat Duke Nukem Forever out the door, much to our shame. But we hope we'll have a little more staying power.
Great, another question. So I'm curious how gradual typing is working out in Perl 6. Do you like having it in the language? Were there any good or bad surprises about having that?
Well, our gradual typing is gradual as far as the user is concerned. The mistake we made in Perls 1 through 5, we allowed the user to be confused about what the type of a scalar value was. Maybe it's a string, maybe it's a number, maybe it's something else. Unfortunately, we did that by confusing the compiler and the runtime system as well. So it had no clue either. So if you happen to use a string as a number as string, it could have weird side effects. In Perl 6, we always actually know what the type is. Now, it might be a more generic type or less generic type, but we have a specific type that we have in mind, even if the user has not declared it. So, literals come with their types. Various operations know what types they're producing. So it works out as gradual typing from the standpoint of the user, the naive user, but then they can add typing. Now, when we put in typing, we discovered that type safety is actually only like about the third most important thing, correctness. I mean, it has its uses in terms of reliability, but there were more important things. Particularly with native types, we can get potentially, at least, as our optimizers get better, much better efficiency with better type information, both ahead of time and JITting. But really, the most important thing that it turned out to be important for was just to support multiple dispatch, because we just use multiple dispatch pervasively, both multi-method dispatch and multi-function dispatch. The real reason that is the most important is extensibility, because I mean, you can get a little bit of polymorphism out of your class structure, but people tend to overuse that. So putting multiple dispatch as orthogonal to that, you can pull in modules of either functions or methods, classes, and it's not like the old days where you wrote a case structure based on your types and then you were locked into that. It's the way to do case structures without locking yourself in. So if you add a new type, you add a new multi for the appropriate operator. Hopefully it's the appropriate one, not an unappropriate one. Goodness, we have all of Unicode for operators now. You don't have to overload less than to do I/O. So it's worked out very well because the base classes and the base modules just don't have to know how they're going to be extended. So that's one of the many ways in which we are supporting extension into the future. That's sort of down on the semantic level, how you delegate, all the, it's sort of almost an inversion of control kind of idea.
Great, thanks a lot.
Okay, let's thank the speaker.